In this video, we are going to talk about how to take derivatives using some shortcut rules. The first rule we're going to talk about is the constant rule. If I want to take the derivative of a number or a constant, that derivative is going to be equal to 0. So for instance, suppose we want to take the derivative of the number 3. So notice this notation, brackets with that apostrophe means take the derivative of what's inside, and we would say that derivative would be equal to 0. The power rule. If I want to take the derivative of x to the n, we bring the exponent down and we subtract 1 from the exponent. So for instance, if I want to take the derivative of x cubed, bring the exponent down, subtract 1 from the exponent, we're going to get 3x squared. This would also work if I have something like 1 over x squared, because I can rewrite that as x to the negative 2. And then I want to take the derivative, so I'm going to bring the exponent down, and I'm going to subtract 1 from the exponent. Negative 2 minus 1 is a negative 3. So this is negative 2 over x cubed. We could even use it for radicals. Suppose we want to take the derivative of the cube root of x squared. We can rewrite that as x to the 2/3. And then we're going to bring the exponent down. And then we're going to subtract 1 from the exponent. 2/3 minus 1 is a negative 1/3. And we could leave it like that. Or we could rewrite this as 2 over 3's cube root of x. Some are difference. What this is saying is that if we want to take the derivative of f of x plus or minus g of x, and that means we could take the derivative of each piece. So it would be f prime of x plus g prime of x. So for example, if we want to take the derivative of x to the 5th minus 2x squared plus 1, we could take the derivative of each piece separately. The derivative of x to the 5th, bring the exponent down, subtract 1 from the exponent. This, we're going to actually use a constant multiple exponent. So we're going to keep that minus 2 in front, and then we're going to bring the exponent down and subtract 1 from the exponent. And then we know the derivative of a constant is 0. So this is going to be 5x to the 4th minus 4x is the derivative. And then the constant multiple rule just says that if we want to take the derivative of a constant times a function, then we could pull that constant out and take the derivative. And that's what we used here to take the derivative of negative 2x squared. So let's just do another one of those. Let's say we have 4x to the 7th, and we want to take the derivative. We're going to keep the 4. We're going to bring the exponent down, subtract 1 from the exponent, and then we're going to clean it up. Let's talk about 2 more rules that we're going to add, product rule and quotient rule. Product rule. So let's use those rules and look at a few of these. Let's look at number 2. If we want to take the derivative of number 2, f prime of x, we're going to use our power rule and constant multiple rules and sum and difference rules. So we're going to keep the 5, bring the exponent down, subtract 1 from the exponent, keep the negative 1 there. Remember, there's an understood 1 there. Bring the exponent down, and then we're going to subtract 1 from the exponent, so that's x to the 0, and then the derivative of 1 is 0, and then we're going to clean it up. So this is 15x squared minus 1 for that derivative. If we have something like number 6, it's going to be easiest for us to multiply this through. Actually, before we do that one, we're going to have to talk about a quotient rule. Let's go ahead and look at number 7 next. So it's going to be easiest for us to take the derivative by multiplying everything out here. So if I FOIL this, I'm going to have 2x cubed. Insides will give us a 4x squared. Outsides will give us a minus 3x. And then last will give us a minus 6. And then we're just going to take the derivative of each piece. So this is going to be 2, bring the exponent down, subtract 1 from the exponent. 4, bring the exponent down, subtract 1 from the exponent. 3, bring that exponent of 1 down, subtract 1 from the exponent, and the derivative of a constant is 0, and then we're going to clean it up. So there's our derivative. And then let's look at number 10. With number 10, it's going to be easiest for us to simplify this. So I can split the numerator and take each of those terms in the numerator and divide by the denominator. So that is 4x minus 2 over x plus 1 over x squared. So I'm just doing a rewrite step here. And this is 2x to the negative 1. And this is x to the negative 2. And then now we're going to take the derivative. So 4, bring that exponent down, subtract 1 from the exponent. Negative 2, bring the exponent down, subtract 1 from the exponent. Then bring that exponent down, subtract 1 from the exponent. And then we're just going to clean it up. So we're going to get 4. X to the 0 is the same thing as 1. So this is just going to be 4 times 1, which is 4. This is a minus 2 times a negative 1, which is a positive 2. X to the negative 2. And then we're going to have minus 2x to the negative 3. And we could leave it with negative exponents, or we could get rid of the negative exponents. So now let's go back to our product rule and quotient rules. Product rule says, if I want to take the derivative of two things multiplied together, I'll call them functions f and g, it would be first derivative of the second plus second derivative of the first. So let's do an example. Let's look at number 7 down here. Okay, we FOILed it out earlier, but let's use the product rule. So f of x, I'm going to recopy the problem. So product rule says it's the first function times the derivative of the second. So I am doing a setup step here. Okay, I have not taken the derivative. This notation means I need to take the derivative. First times derivative of the second plus second times derivative of the first. And again, this is showing a setup step. This notation means I'm going to take the derivative of the first. And now I'm going to do that. So the derivative of 2x squared minus 3. If I bring that exponent down, I'm going to have a 4. And this is going to be x to the first. And the derivative of minus 3 is 0. First times derivative of the second plus the second times derivative of the first. And the derivative of x plus 2. The derivative of x is going to be 1. Remember, we'd have a 1. We'd bring that exponent down. And then we would subtract 1 from the exponent. And the derivative of 2 is 0. And then we're going to clean this up. We're going to distribute. So we're going to get 4x squared plus 8x plus 2x squared minus 3. And then we're going to combine like terms. 6x squared plus 8x minus 3. And you can see how we got the same thing that we got before. Quotient rule. Quotient rule says we want to take the derivative of a quotient, so I'll use f and g again. It says it's bottom times derivative of the top minus top times derivative of the bottom all over the bottom function squared. And that's how we would take the derivative of something like number 11. So for 11, we've got x squared plus 4 over x squared minus 4. So to find the derivative, we're using the quotient rule. Quotient rule says it's the bottom times the derivative of the top. So I'm doing a setup step. Minus the top times the derivative of the bottom all over the bottom squared. So now we're going to take the derivative of the pieces here and here. So bottom derivative of the top is going to be a 2x minus top times the derivative of the bottom. The derivative of this would be 2x all over x squared minus 4 quantity squared. So now we need to simplify. So there's a couple of ways we could do that. We could distribute in here. So we're going to have 2x cubed minus 8x. And then I'm going to distribute that 2x here. 2x cubed plus 8x over x squared minus 4 quantity squared. And you can see how these are going to cancel. I'm going to have negative 8x minus 8x, which is a minus 16x over x squared minus 4 quantity squared. And then now we could go back and do something like number 6. So I'm going to copy that problem down here. So what I would want to do is distribute here. Okay? I would not want to use the product rule with a quotient rule here. So I would want to simplify. So 3 times 18 is a 54 x to the 5th plus 3 times 13 is 39x over x plus 1. So now we're in a place where we could take a derivative easily. We know the derivative of this guy. We're going to bring that exponent down. So we're going to have 5 times 5, which is 25, and then we're subtracting 1 from the exponent. And then now we got to take the derivative of this, and this will be a quotient rule. Quotient rule says it's the bottom times derivative of the top. So I'm doing my setup. Minus the top times the derivative of the bottom over the bottom squared. So I'm going to have 25x to the 4th plus, and then let's simplify this. The derivative of 39x is just going to be 39. And the derivative of x plus 1 is going to be 1 plus 0, which is 1, over x plus 1 squared. Let me clean up this term. So we're going to distribute. So we're going to have 39x plus 39 minus 39x all over x plus 1 squared. So 25x to the 4th. Those are going to cancel, leaving us with a 39 over x plus 1 squared.